Math 3, Unit 10, final review. So this is where we're just going to go back through all the trigonometry that we learned. So you need to make sure you remember SOHCAHTOA and what each of them stand for. Okay? So these first examples, they ask you to solve for x without using a calculator. So if you look here, you have 65 degrees. Based on this angle, we know 8 represents adjacent, opposite, or hypotenuse. Opposite. And the x represents, so therefore, we are going to take the sine. So sine of 65 equals 8 over x. Now our goal is just to get x by itself. How do we do that? Start by eliminating the fraction. How would I eliminate the fraction? These cancel. We have x times sine of 65 equals 8. And then what would I do next?
Divide by the sine of 65.
Good. So x equals 8 over sine of 65.
Borrow this.
Sure. Okay, next one. So this one is a little different because it's dealing with the angle. But if you look at the angle, what two pieces of information have they given me?
Cosine.
Good. It's cosine because we have adjacent and hypotenuse. So when I originally write this out, it is cosine of x equals adjacent, which is 11, over hypotenuse, which is 17. Now, if you were finding this answer from your calculator, you would write or type in cosine to the negative 1, and then you'd put in that fraction. And that would equal x. So this is my answer. This is how I'm writing. I'm not using a calculator. Okay? So in order to find the degree, you would do your inverse function, which is cosine to the negative 1 of the fraction, and that equals your degree. Are there any questions there?
So this is what we'll be using on our final.
Yeah, so this is what you would use on your final. Okay, what is a coterminal angle? So remember, coterminal means that you can have different degrees that end at the same spot on the circle. Okay? And so, to find coterminal angles, all you do is add or subtract 360 degrees. Or if you're dealing with radians, you would add or subtract 2 pi. So we're going to practice this. So they want us to find 2 coterminal angles, one positive and one negative for each of the following. Now, 290 degrees, just to remind you of where this would be. What quadrant would that be in, that angle? 4, right? Because this right here is 270, so 290 is actually a little bit past that. And so if you were drawing that, you start at 0 and it wraps around to the 270 degrees. So a coterminal angle is where you would end up starting here, and then you'd end up going around again and still ending at that mark, but it's going to be a different degree because it's gone around the circle one time and then ended back up at the same spot. So you find that by adding 360 degrees. So 290 plus 360 equals 650 degrees. To find the negative, you would subtract 360. Now, normally when we're subtracting, we want the bigger number on top. And so I'm going to subtract 360 degrees from 290. So you end up getting 70. But it's not 70, it's very good. Negative 70 degrees. So those are my 2 coterminal angles. Okay, for radians, it's the same thing, okay, except for you're dealing with your 2 pi. So if I take 4 pi over 7 and I'm adding 2 pi to it, what do I end up having to do if I'm adding fractions? Good, we need common denominators. Right now that denominator is 1. So in order to make this denominator a 7, I would have to multiply 1 times 7. And whatever you do to the bottom, you also have to do to the top. So that means here I have 4 pi over 7 plus 14 pi over 7. You add those together and you get perfect 18 pi over 7. So that is my positive coterminal angle. And for the negative, we're going to do the same thing. Okay, so we have 4 pi over 7 minus 14 pi over 7. Because I already figured out what my common denominator is. And so we end up with what there? Good. Negative 10 pi over 7. So those are my 2 answers. 18 pi over 7 and negative 10 pi over 7. Any questions? We're good? Okay. Okay, the next thing is a reference angle. Okay, a reference angle is the positive angle between 0 and 90 degrees. Okay, so it's between 0 and 90 or between 0 and pi over 2 radians. That represents the angle between the terminating ray and the x-axis. So remember that reference angles always go up to our x-axis. So 320 degrees. If I am drawing that, where is that going to go to in terms of quadrants?
4.
Quadrant 4. So if I were to draw this angle and go here to quadrant 4, this is 320 degrees. Your reference angles, wherever it stops, is always going to go up to the x-axis. So this goes up to the x-axis, and so what will that end up being?
40.
Very good. So in this case, we were taking 360 minus 320, oops, which made 40 degrees. And most of you can figure that out. To get from here up to here, 40 more degrees. Okay, now 8 pi over 11. Do you guys, so if we're doing it in terms of 11, okay, if we were to write these out, so I want a denominator of 11, what would go on the top so that this would reduce to 2 pi? 22 pi. Okay? Over here, if I want a denominator of 11, what's going to end up going on top? 11 pi. Okay? And then remember here, this is where we take 11 and we divide it by 2, which would be what?
5.5.
Very good. And then we just add 5.5 to 11, and so the bottom one is going to be what?
16.5.
Oh.
Okay, 16.5 pi over 11. Okay, so if we're drawing this, which quadrant is 8 pi going to be in? Very good. So we're going to go ahead and draw this reference angle. And so now that we're looking here, my reference angle, again, it always goes to the x-axis. Okay, so right here. So basically, we're trying to figure out what's it going to take to get to that line. Good. 3 pi over 11 is correct. Any questions? Okay. Converting between radians and degrees. Okay, so basically remember that you're either going to multiply by 180 over pi, or you're going to multiply by pi over 180. So it just depends on, do you want to put pi into your answer, or do you want to get pi out of your answers? Okay, so on this one, if it's in degrees, that means we want to turn it into radians, which means we want pi into our answer. So all you're going to do is take 20 degrees, and we're going to end up multiplying that by pi over 180. Okay, and so we're just going to reduce. Since I have a 0 on the top and a 0 on the bottom, those just cancel, and then 2 goes into 18 how many times? 9. And so in terms of radians, the answer is pi over 9. 20 degrees is pi over 9. Okay, now this one is in radians, so therefore we want to eliminate pi and turn it into degrees. So instead of multiplying by pi over 180, we're going to multiply by, very good, 180 over pi. So 7 pi over 9 times 180 over pi. So first thing is that the pi's reduce. 9 goes into 180 how many times? 20 times. And then we have 7 times 20, which is 140 degrees. Any questions? Okay. The unit circle. So right now, we would have normally taken a few minutes to complete the unit circle, but we're going to go ahead and skip that here for a minute. If you have a unit circle that you want to take out, you can. And I'm going to take one out that we'll kind of look at. And so it says, determine whether each of the following statements are true or false. Now, you need to remember that cosine is dealing with x and sine is dealing with y. Do you guys remember how we remember which one goes with which letter?
Cosine is x.
Alphabetical order. That's how I remember it. And you might remember it differently, but I know that x comes before y and c comes before s. So alphabetically, cosine and x go together, sine and y go together. Okay, and tangent is just like slope, where you're putting your y over your x. Okay? So here it says, if the terminating ray is in quadrant 1, sine of theta is greater than 0. So what that's saying is that sine would be positive. So a positive, wait a second, let's take this back. Okay, we're looking in quadrant 1. In quadrant 1 is sine positive. Sine is dealing with what? Y's. So in this quadrant right here, our y's positive. Yeah, sine is positive, y is positive above the x-axis because y's are positive going up. Okay, and so in quadrant 1, sine is positive. Is a positive greater than 0? So this one is true. We're just doing true or false.
True.
Okay, so this next one we're talking about cosine. So cosine is dealing with what? X. Okay, and we're only looking at this quadrant right here. X is what in that quadrant? X is negative. Does everybody agree with that? And so is a negative greater than 0? That is not true. Okay, and so this is false. Okay, this next one we're talking about quadrant 3. Tangent. Now remember, tangent is y over x. So in this quadrant down here, the y is what? The y is negative divided by the x, which is negative. And two negatives end up making a positive. So this is positive. So is a positive less than 0? No, not true. And so this one also is false. Okay, last one here. Quadrant 4, again, we're dealing with tangent. Tangent we know is y over x. So in this quadrant 4, the y value is what? negative, over the x value, which is positive. And a negative divided by a positive is a negative. So is a negative less than 0? Yes, so this one is true. Any questions? Okay. Let's move on.
Bless you.
Bless you.
Thank you. Hold on.
Okay, so this is where your unit circle is going to help a lot. Okay, cosine of 210 degrees. So first of all, cosine is dealing with what? X. So on your unit circle, you go to 210 degrees, and what is the x value there?
It is negative root 3 over 2.
Good. That's your answer. Negative root 3 over 2. Sine is dealing with your y. So we go to 315 degrees. And what is my y value? Negative root 2 over 2 is correct. Tangent is what? Y over x. Good. So 390 degrees. This is where you want to find the exact spot in the circle. So I'm going to end up subtracting 360 because this is going to end up terminating at what? Tangent of 30 degrees. Okay? And so 30 degrees is here. Do you guys remember what you do?
Yeah, you can have a root in the denominator, so you have to multiply by that.
Well, okay, but right here, if we're doing our y over x, so you're right, you just skip the first step. Remember that you're only dealing with the numerators, so y over x is going to be 1 over root 3. And again, we can't have a root in the denominator, and so we rationalize it. Good, it's going to be root 3 over 3. If you forgot, you get that by multiplying root 3 to the top and the bottom, because 2 root 3's end up making just a 3, and then we have root 3 on top. Because 1 times root 3 is just root 3. Any questions there? Okay, again, cosine is dealing with what? X. And so at 180, what is my x value? Any questions? Okay, so now we're dealing with radians. If they give the problem to you in radians, you keep it in radians. Okay, sine is dealing with your y. So 3 pi over 4 is here, and so my y value is root 2 over 2. Okay, next question is tangent of 11 pi over 6. Tangent is y over x. So 11 pi over 6, where do we go? Quadrant 4. And then y over x is going to be what? Good. Good. Negative 1 over root 3, but we would need to rationalize it by multiplying by root 3 to the top and the bottom, and you get negative root 3 over 3. Okay, cosine is dealing with x. 4 pi over 3. And it'll be what? Negative 1/2. Okay, and then we have tangent, which is 3 pi over 2. Okay, so tangent is what? Y over x. So that means we're going to write what? Good. Very good. Negative 1 over 0, but you can't have a 0 in the denominator, so that answer is no solution. If you had a 0 on top, then the answer would just be 0, and there is a difference between them. Okay?
What's cosine 180 on the top?
cosine of 180. Oh, negative 1. Because you're at the 180 mark, the x value at the 180 mark.
Yeah, just good.
Okay, any questions? All right, so these next ones we are solving or finding these answers as well. We're trying to find, if you notice here, they're asking us to state the answer in terms of degrees. If it had, 0 to 2 pi, we'd be answering them in terms of radians. Okay, so where is cosine negative? Cosine is dealing with our x. Okay, where is x negative? Which quadrants? 2 and 3. Okay, so that means, gentlemen, can you please stop? You're just being rude. Okay, so we are looking for what degrees is x negative root 3 over 2. So we know that negative root 3 over 2 should be in quadrants 2 and 3. So where is the x value negative root 3 over 2 in quadrant 2? 150. We're going to start here at this one. Okay, so 150. And then in quadrant 3, it is 210. Good. So that's it. That is your answer. Okay, next one. Tangent's not by itself. What do I need to do? Good. Get the trig function by itself. So we have tangent of theta equals negative 1. Where is tangent negative in terms of quadrants? Good. Quadrants 2 and 4 is correct. Because remember down here, this is a negative, which ends up making a positive because tangent is y over x. Okay, so putting a y value over an x value, which one of these would end up reducing to be negative 1? 135 degrees is correct, because root 2 over negative root 2 would reduce to be negative 1. So 135 degrees. And then the other one, our other degree would be what? Okay, any questions? Okay, these last ones here, they want us to state them in terms of radians. Okay, and we're going to actually change this to be 2 sine theta equals root 3. What are we going to do in order to get sine by itself? So sine of theta equals root 3 over 2. Okay. Clark is here today. The incoming freshmen are getting a tour. No, you may not.
Why not?
They probably need a tutor as well. No, I'm just kidding. Oh, really? That's funny. Okay. Sine is dealing with what? Y. Okay. Where is sine positive? Where is y positive? 1 and 2. So we're going to go to quadrants 1 and 2, and we're going to look for where is y root 3 over 2. 60, but we want it in terms of radians, so we're going to write that as pi over 3. Okay, and then I know there's going to be another one in quadrant 2, so where is y positive root 3 over 2? 2 pi over 3. Okay, any questions? Okay, next one. This has already been factored for you. So this is where you're going to have two different equations for the same problem. So here, this is going to be cosine of theta equals 0. And then we have 2 sine of theta minus 1 equals 0. Okay? This has already been solved. Cosine is dealing with x. Where is x? 0. Good. And in terms of radians, that would be? Good. Pi over 2 and 3 pi over 2. This one, sine is not by itself, so what am I going to do?
You would add 1 to both sides.
Good, add 1 to both sides.
Divide by 2.
2 sine of theta equals 1, divide by 2 to both
Then you
sides.
get sine equals 1
Sine is dealing with the
over
y value. This is, sine is positive, it's a positive 1/2. Where is sine positive? Where is y positive? Which quadrants? 1 and 2. So that means we're going to look for a y value that's positive 1/2 in quadrant 1, which is what in terms of radian? Pi over 6. And then in quadrant 2 will be where? 5 pi over 6. So this answer actually, or this question had 4 answers. Do we have any questions? Okay. Sine and cosine graphs. Okay, so here's your original sine and cosine graphs. And now we're going to do some examples. Do you guys remember what this number in front represents?
The amplitude.
Very good. The amplitude. And it's always positive because you always end up going the positive direction and then also the negative direction. And so this amplitude is 2. The negative in front just means that normally with sines you start going up, but instead of starting going up on this one, you would end up starting going down. Now remember with sine functions, you have 3 points that you start with at 0, pi, and 2 pi. And what I'd like us to do is just put x's at 0, pi, and 2 pi, and then we're going to shift them based on the information that's given in our equation. Okay? And so this plus 1 right here, what does that mean we're going to go? We're going to go up 1. Good. So from each of these points that I originally made, I'm going to go up 1. And I'm going to actually make my points there. So you just have to remember that x's don't really count. That's just where you're starting before you move things around. And if you want to go back and erase them, you could. Then we go in between these 2 points that we have. Okay? And so we're going to start, because normally we'd go up 2 and make our next point, but instead we're going to go down 2 because of the negative in front. Okay? And then you go in between these 2 points. And since I went down, now I have to go up. And then you draw your curve. Oops, tried to do it better than me. So let's go ahead and go down and practice the other sine function, okay? So again, for sines, our original starting point is always going to be at 0, pi, and 2 pi, which I'm going to mark my x's. My amplitude on this one is going to be what? 3. Good. Now, whatever is in parentheses, what do you end up doing? Opposite. You set them equal to 0, it ends up becoming the opposite. So that's going to be left pi over 2. And then this is going to be down 2. Remember that pi over 2 is these little marks, okay? So each of these marks are half of a pi. So if we're going left pi over 2, we're going left 1 mark, and then we're going down 2. So from this x, I'm going left pi over 2, down 2, left pi over 2, down 2. Okay, then we go in between our 2 points, and we normally always go by starting up unless this is negative. So I'm going to end up going up how many? 3. 1, 2, 3. Okay, and in between these 2 points, I go
You can go up 3.
down 3.
Go down 3.
Any questions? Okay, so cosine graphs. So how sine graphs, our starting points were at 0, pi, and 2 pi. Cosine is the opposite. So your starting points are at pi over 2 and 3 pi over 2. So I'm going to mark my x's here. So cosine are just the points in between the 3 of the sines. Okay? What that means though, because you're always marking 5 points, just like you normally started up on all the sine graphs, on the cosine, same thing. You'll start up, but it's just on the left of the x. So it'd start up, and then in between these 2, it'd go down, and then after this one, it goes up. But you always end up with 5 points. On this one, my amplitude is what? 3. And this means I'm going to do what? Good. Right pi over 2. So that means for each of these x's, I'm going to go right 1 mark, because each mark is pi over 2. That's my point. From this x, I go right pi over 2, make my point. So cosine, because we only have 2 of our points at our 0 line, we have to start to the left. Okay, we always start up unless there's a negative in front. So from here, I'm going to go up how many? 3. 1, 2, 3, because my amplitude is 3. Then you go to the right. We go in the middle of these 2 points, and I'm going to go down 3. 1, 2, 3. Because you always go in a pattern. Up, down, up. Okay, or with sine, it's up and down. Okay, and then you go after this point, which means since I've gone up and then down, I'm going to have to go up. 1, 2, 3. The cosine graphs almost look like a parabola, where your sine graphs is more of the wave. Do you have any questions there? Okay, last one here. What is my amplitude on this one? 2. Amplitude is always the value in front. Okay? This means I'm going to move it which way? Good. Left pi, which means that it's actually 2 markings, right? Because each marking is pi over 2. So left pi will be 2 markings, and then plus 3 means I will move it up 3. Where are my original cosine marks? In between there and in between pi and 2 pi. Okay? So when we're going left pi, how many am I going left? How many marks? 2 marks, which is pi. So I went left pi and then up 3. 1, 2, 3. For this marking, we're going left pi, so we're going left 2 and then up 1, 2, 3. Okay, so where do I go once I have these marks? We're going to go to the left of each of the marks. Okay, so the left here, how many am I going to go up or down to begin with? Down. Why down? Because of that negative. I have to start down. If you forget that, when you see the negative, tell yourself, start down. Okay, so from here we go down, and how many am I going to go down? 2. So that means in between those 2 points, I'm going to go up 2. And then to the right of this, I'm going to end up going down 2. And that's it. Any questions?